Hey guys, here I am again. It's been a while and I actually just had COVID 2 weeks ago, but now I'm fine again and I hope you are also doing well. And hi also to my new subscribers. Yeah, I'm very happy about this channel growth in the last time and yeah, thank you. If you not already subscribed, please subscribe not to miss new videos and yeah, this would help me a lot. So after about 5 weeks, we will also have a clear night tonight and most probably also tomorrow. So let's see. So this is a very nice chance for me to finish two long time projects. I talked about, I think, two videos ago. I started several long-term projects. In total, I started shooting on 4 deep sky objects. So let's see how this will work. And yeah, so weather is nice, clear sky, 5% moon. So very good chance to really finish those two projects. So in this video I will show you the result of my third long-term project, and in the next video I will show you the result of the fourth project, long-term project, so don't miss it. And the target I selected for the third long-term project is NGC 3198. It's a very nice, actually a beautiful galaxy. And in fact, it's the most distant object or main object I ever targeted or captured. It's about 30 million light years away from us. So crazy. It's really crazy. So why this target? I think it's as I said before, it's a beautiful galaxy, but it also has something to do with what I can see from my home. So yeah, as you can see here in Stellarium, I have a quite narrow corridor of what I can actually see. So I have many buildings here. I have trees, high trees. And I also have on the other side or between the buildings, I also have a light, street light, and which is very bright. So actually I'm quite limited to what I can really target. So NGC 3198 is a Barrett spiral galaxy, and it was discovered by William Herschel in 1788. And here, for example, you can see a photo of a plate of this galaxy from 1978. And I really hope I can make a better picture than that. In fact, this galaxy was one of the 18 initial targets or key targets of the Hubble Space Telescope to really determine or refine calculations for the Hubble constant. So it's also scientifically, it's a very interesting target, or it has been a very interesting target. And besides that, 2 supernovae were discovered in this galaxy, and here you can see a photo of the second one. So the first one was observed in 1966, and the second one, which you can see here, was discovered in 1999. On the left hand side you can see a picture of this galaxy from April 99, and on the right hand side you can see a picture from May 1999. And this galaxy also has been one of the first galaxies to really determine or investigate dark matter. So let's just shortly speak about dark matter. So according to physical laws, when you have a more dense structure like the core of a galaxy, where you have many stars, you have a higher mass. And the rotation speed when you have a high mass is quite high. So actually what we can see is we have quite a high mass in the core of a galaxy and less mass or density to the outer regions of a galaxy. So what we actually would expect to see is the rotation speed, which is quite high in the core and which is quite low in the outer regions of the galaxy. And this, from a simulation, should look like this. So as you can see here, in the core you have a quite high velocity, rotation velocity, and in the outer region it's slower. But what you actually measure is this. So you really have a quite high velocity in the core region, but when you go to the outer regions of a galaxy, you have still quite high velocities, and actually it looks quite constant. So this is an indirect indication for dark matter. This means somehow there should be a quite high mass in the outer structure of a galaxy which we cannot see. So we can see a quite high velocity in the core region of a galaxy, but we also can see quite high or constant velocities in the outer regions, as you can see here. So with distance from the core of a galaxy to the outer regions, the velocity is quite constant. And this is an indirect sign for dark matter, because if you have those high velocities, that means you somehow have a quite high density or high mass in outer regions. So NGC 3198 was one of the initial galaxies to really investigate dark matter or effects of dark matter on the velocity or the rotation speed of a galaxy in inner and outer regions. So very interesting object. And this is actually what you can see in the intro of my videos. So as you can see here in the short sequence, you have almost or exactly the same velocity or rotation speed in the core of a galaxy compared to the outer region of the galaxy. So actually it behaves like a vinyl record or something. And this is a indirect evidence or indirect sign, let's say, for dark matter. So very interesting. But let's stop talking. We have a quite short night for imaging, and so let's do this. Yeah, so that's my final image of this galaxy of NGC 3198, and yeah, I'm quite happy with it. Of course, you have to take into account that I'm using a 2.1 megapixel camera. It's actually a planetary camera. It's also suitable, as you can see, for deep sky objects. but it's really more a planetary camera, and for this I'm quite happy. What I always see is I have really quite a high amount of noise. I'm very happy with the quality of the image and so on, but I'm really always struggling with quite high noise. So it's an uncooled camera, but yeah. But as I said, in summary, I'm very happy with the result, and I hope you like it as well. And from now on, I try to capture one object for at least 8 hours total integration time. Yeah, it's not so easy from my position, as you can see. So yeah, I have this tree, and on the other side it's quite bright because of this traffic light and so on, or street light. And yeah, but in the future I really want to try to have yeah, let's say a longer total integration time. Yeah, so thank you for watching, and see you next time. Clear skies.